Hi, welcome to our first video for Chapter 4, our trigonometry unit. In this video, we're just going to review some of the concepts that you would have learned in your grade 10 trig unit. Okay, let's begin. So it says if we know a right triangle has an angle of theta, so here's an example of a right triangle, because we have this symbol here, it means there's 90 degrees. So it says if it's given an angle theta, then it says all other right triangles with the same angle theta, so like maybe this one here also has theta, also right angle. So it says they're going to be similar. What that means is this triangle has to be similar to this one. Why? Well, because they have the same angles inside. And if they both have 90 here, then that means this angle needs to be the same too. So if they have the same angles, then what that means is they're going to have equivalent ratios for their corresponding sides. Okay? So what it means is this side length here, I'm going to call it O for opposite because it's opposite to theta. The ratio of this side length to this side length, so like here to here, that ratio is going to be the same as it is for this side length. Sorry, we'll call that A. For this side length to this side length. And also for this side length here, I call it H for hypotenuse. So the ratio of this side length to this side length is also going to be the same. So that's because they are similar triangles. They have the same angles, so their corresponding side lengths are going to have the same ratio. Meaning I could multiply this side length by a number, I multiply it by something, and I get this side length. And if I use that same factor, I can actually go from each side length and get the corresponding one. They're all going to be multiplied by the same factor. That's what similar triangles are. Now, what's also true is the ratio amongst its own side lengths. So like O over H, this ratio is going to be the same as this O over this H for that triangle because they're similar. And same with O over A. They're all going to be equivalent ratios. So you can think of it as like a test score. This could be like a small test. Maybe you got, let's say you got 8 out of 10. Well, on a bigger test, maybe you got 80 out of 100. You still got the same percentage, still got the same score. It was just a bigger test. That's how similar triangles work. So these ratios that I'm talking about between the side lengths, like O and A, O and H, well, we have names for them. They're part of the 3 primary trig ratios for a right angle triangle. First one's called sine, the second one is called cosine, and the last one is called tangent. So the way to remember the ratios is to use this acronym here, SOHCAHTOA. So basically, when you're given a right angle triangle and you have theta, the side directly across from theta is always opposite. This side that's touching the angle is called adjacent, and this side that's also touching the angle is called hypotenuse. The difference between those two is that the hypotenuse is always the longer side length. Okay. So sine is going to be opposite over hypotenuse. Okay. It just kind of is that way, and that's how it works out for the acronym too when we remember it. We remember SOHCAHTOA. So cosine of this angle is going to be the adjacent over the hypotenuse. So A over H. And then lastly tan is opposite over the adjacent. So what this means is these 3 trig ratios here, the primary trig ratios, they're going to be true for any right angle triangle that has this angle theta. Doesn't matter how big or how small, if it has an angle theta, it's going to have this trig ratio. And if the angles are the same, they're going to have the same ratio. Okay, so let's use the SOHCAHTOA in order to find some missing side lengths or angles, because that's really what trigonometry comes down to. Like Doesn't matter what math course you're in, you're usually solving triangles and you're trying to figure out a missing side length or a missing angle and then apply it to real life problems. So let's go ahead with these two. These are both right angle triangles. You can see that here. And we're given this angle 30 and we're given the opposite length. Okay, so I'm going to write that in here, O for opposite length. And we're looking for this missing side length, which happens to be the hypotenuse. So which trig ratio relates opposite with hypotenuse? So this is where we want to scan our acronym and look for one that has opposite and hypotenuse with it. So it's definitely not these two. This one is O and 8, so it's going to be sine. So let's write it out. Sine of 30 degrees equals opposite over hypotenuse. So the next line here, I'm just going to fill that out. You can always do this in the first step. Opposite is 1 because it's directly opposite to the angle. And the hypotenuse here is x, it's the longest side. So we have 1 over x. Now we need to find x. We want to isolate for it, to solve for it. So let's multiply both sides by x. That way it cancels out on this side. So then we're left with x times sine of 30 equal to 1. Okay, we almost got x by itself. Just divide both sides by sine 30. That'll cancel out this side. And there we have it. X is equal to 1 over sine of 30. Okay, well, how are we going to calculate this? Well, we're going to have to use a calculator at this point. So we can do 1 divided by, now I'm going to use my function button in order to access sine. And there is sine right here. And I'm going to put 30 in. Before I do so, I'm just going to check Desmos, make sure I'm in degrees. Sometimes it starts off in radians, so we want to make sure we're in degrees. You should do the same thing on your calculator. On the TI-84, you can just hit mode, and I believe you can scroll down and make sure your angle is set to degrees. Most other calculators, you might have to hit a mode button as well. So, okay, so let's put our angle in 30. So 1 divided by sine of 30 works out to a clean 2. All right, so that actually means this side length here is 2. So it's kind of cool. We have a 30-degree triangle, and this side length is 1. The hypotenuse is actually twice the size of the opposite. What that tells me is if I apply similar triangles, if I had let's say, a larger triangle that was also 30, and if this was 2, then I know this side length needs to be 4, because I know the trig ratio for sine is basically it's going to have a 1 to 2 ratio. Okay, this next one here. Now we're looking for the angle. Okay, we're still going to take the same approach. It's a right angle triangle. So we're going to use one of these trig ratios here. So I just identify what we're given. This is the adjacent side. And then this side here is the hypotenuse because it's the longest side. So which trig ratio uses adjacent hypotenuse? Well, it's going to be cos. So we can start by writing that out. We can write cos theta equals adjacent over hypotenuse. And now we don't know theta, so we're going to leave it as blank. I'm going to plug in my a and h. So a is root 2, h is 2. And now I want to find theta. So I need to get theta by itself. So right now we have cos of theta. I need to reverse that cos part. So there is a way to reverse it. It's actually called the cos inverse, like we did with inverse functions. So we have cos inverse. So that cancels out the cos, and we're left with just theta on this side. And then we got to do cos inverse of the other side. So cos inverse of root 2 over 2. This is easy to put in the calculator. You might have to hit the second function, depending on your calculator. So I'm going to go into here, and there's my cos inverse. It's got the -1. It means cos inverse. Okay, and then I'm going to put in my ratio, which was root 2 over 2. Make sure your denominator is not in the root. Okay, and we have 45 degrees. So there we have it. We just use one of the trig ratios to find missing angle. Okay. One other rule I want to talk about for right angle triangles, and that's Pythagorean theorem. Okay, and I know we've used this a lot and you probably remember it. And it just means if you have a right angle triangle, let's say we have side length A, B, and C, and it is right angle. Well, we know that the hypotenuse squared is always equal to the sum of the other side length squared. So sum of the squares for the other side lengths. So this side squared is always equal to this squared plus this squared. That's Pythagorean's theorem. So we can always apply it to right angle triangles. So if you're ever given a question where you got two side lengths and you need a third, well, you can go ahead and just use Pythagorean's theorem. You could probably also use a trig ratio too as well, but that is there for you in case you need it. Okay, that's it for this video. I'll see you guys in the next.